Okay, so this is going to be the solution video for the Hess's Law worksheet, right? So we're looking at this one here. And so this worksheet is asking us to do a couple different things. And so in this first section, we want to write formation equations. And so the important part when you're writing a formation equation is you have to end up making just 1 mole of the species you're interested in. So if we're looking at this, we're making just 1 mole of H2O. It's a liquid, and that's coming from our elemental state. So hydrogen ends up as H2 as a gas, and oxygen ends up as O2 as a gas. And since we're only ending up with 1 mole of the H2O, then we can actually have this half coefficient in front because we only need half of that O2 because we only need 1 oxygen atom. This next one looks very similar to the one we just did because we're starting off from the same elements. We're making H2O, but this time we're making it as a gas instead of a liquid. CO2, we have carbon as a solid plus O2 as a gas, going to CO2 as a gas. C2H4, that's going to be 2 of those carbons as solids, plus 3 of those hydrogen molecules, going to C2H6. C3H8, so 3 carbons, 4 hydrogen molecules, going to C3H8. And then 4 carbons is a solid plus 5 H2s as a gas, goes to C4H10. All right. And so now we're trying to use these equations that we just wrote to calculate this combustion mod. Now, we're trying to figure those out for both our, so for this combustion of CH4, we're eventually going to also want to figure it out for C2H6. And so we're trying to go back and look at what we're, at how we can use those equations to make that happen. So when I look at this, well, I think my CH4, well, we should use that first equation, CH4 as a gas, coming from C as a solid, plus 2H2 as a gas. And my CO2 is coming from carbon as a solid, plus O2 as a gas, going to CO2. And my H2O is coming from H2 as a gas, plus 1/2 of our O2 as a gas, going to H2O. And I need 2 of those, so I should have 2H2, 2O2, making 2 H2O waters. So looking at this, I'm going to go ahead and write it over on this side. We have a CH4 plus carbon as a solid plus O2 as a gas plus 2H2 as a gas plus 2O2 as a gas, going to carbon as a solid plus 2H2 as a gas plus CO2 plus 2 waters. And then canceling what's on both sides, our carbon cancels with our carbon, our H2 with our H2, and our O2s. They go ahead and get combined. Now, this isn't balancing out. Oh, that makes sense. This shouldn't be 2 O2s. This should be 1 O2. That makes more sense. I was like, that's not going to balance out. And that's because 2 times 1/2 is 1, not 2 times 1/2 is 2. There we go. And so now we have CH4 as a gas plus 2O2 as a gas, going to CO2 as a gas plus 2H2O as a gas. That's exactly the equation we're looking for. And so now I just need to tie in my heats of formation. So for that first equation, we flipped it. So it should be a positive 74.8 kilojoules per mole. The second equation, exactly as it's written, so negative 393.5 kilojoules. And the bottom equation is going in the right direction, but we doubled it. So this should be 2 times negative 241.8. So I'm going to add those together. 74.8 minus 393.5 minus 2 times 241.8, which is 483.6. And so when I add all of that together, I get negative 802.3 kilojoules. So this delta H of combustion is negative 802.3 kilojoules. All right. Looking at the C2H6, well, we're getting that same type of equation. We have C2H6 as a gas plus some number of oxygens going to CO2 as a gas plus H2O as a gas. Now, if this is H6, then that means I need 3 of them. I need 2 of them here. Total, I am going to need 5.5 O2s, right? So what I can do is I'm going to go ahead and double that. Well, okay. So for my heat of my combustion, I am looking for this specific one because we want to use 1 mole of my C2H6. So that's going to give me 3 oxygens for 5, 6, 7 oxygens. So that should be 7O2 or 3.5. O2 molecules. Looking at our pieces, right? C2H6 becomes two carbons and 3 hydrogens. And that's delta H is going to be 84.7 kilojoules because I flipped its direction. My CO2 staying the same. So carbon plus plus O2. And its delta H is negative 393.5. It's going in the right direction. I'm going to go ahead and multiply that by 2 because I need 2 CO2s. My water is going to be H2 plus 1/2 O2 going to H2O. Delta H of that is negative 241.8. And then I need 3 of them. When I look at all of that together, you can see that my O2s are going to combine, but my carbons are going to cancel. My hydrogens are going to cancel. And so we get something like C2H6 plus 2 plus 1.5, that's 7.5 O2, going to 2 CO2 plus 3 H2O. And so my delta H should be those corrections I made to all 3 of them. 84.7 minus 393.5 times 2 minus 241.8 times 3. And we get a whopping negative 1,427.7 kilojoules per mole. All right. So that's how we can use Hess's laws to kind of figure out a mystery equation, one that we didn't know. But we can kind of piece it together from the ones that we have above. And so the goal is trying to identify your unique parts, right? So CH4, I knew had to come from my formation equation on my CH4. My CO2 with my CO2, my waters with my waters. And so now I'm just trying to arrange them in the correct order so that way we can solve them. All right. Now they're giving us a new set of reactions. So now they heat a formation reaction. But similar idea. And so I'm looking at this, and I notice that this has nitrogen monoxide. So I'm looking at these ones down here, and this nitrogen monoxide is here, and it's a product, but I want it as a reactant. So that tells me I'm going to need to flip this one. So that way I can get that nitrogen monoxide onto my reactant side. Looking at this, I have my nitrogen dioxide, and that's both product on that side, so I don't need to flip that. but I do need 2 of them. And so we do have that, making 2 of them. So that leaves me to 2NO gas going to N2 gas plus O2 gas, which has a delta H of negative 180, because I swapped it, going with N2 as a gas plus 2O2 as a gas, going to 2NO2 as a gas, and its delta H is still the same, 68 kilojoules. Now my N2s cancel, one of my O2s cancel, and so I'm left with 2NO as a gas plus O2 as a gas, going to 2NO2 as a gas, and it has a delta H of negative 100, and I believe that's going to be 12, but let's double check. Kilojoules per mole. Pretty straightforward. So looking at what we've done each time, every time our compound is a reactant, what do we need to do to the equation? We're going to need to flip it. And what do we do to this now double H? We change the sign. We inverse it. What if a compound is a coefficient of 3? What do we do to the equation? Multiply it by 3. What do you have to do to the delta H? You multiply it by 3. So the shortcut version of Hess's law is going to be that our sum of our delta H of our products minus the sum of our delta H of our reactants is going to be equal to the delta H of the reaction. So looking at our butane, we can see that this is C4H10 gas plus some amount of O2 is going to make 4 CO2s as a gas plus 5 H2Os as a gas. And so this ends up being 4 plus another 2.5, so 6.5 or 13 over 2. And so we have our heats of formation. So looking at this, that becomes, well, the delta H of our formation for this one is negative 125.6. This is going to be 0. CO2 is negative 393.5. And our H2O is negative 241.8. So we want our products. So 4 times negative 393.5 plus 5 times negative 241.8. So that's all of our products. And we're going to subtract from it our reactants. So we have negative 125.6. And then we would have 13.5, 0. And that's because it's in its elemental form. And so 4 times negative 393.5 plus 5 times negative 241.8. This gives us negative 2,783 kilojoules minus a negative 125.6. And so we should be getting negative 2,657.4 kilojoules. All right. So the last equation is it's saying, okay, well, we don't know this heat of formation for C3H8, but we do know what it is for that reaction, the combustion. So we know that its delta H is 2,220 kilojoules, but that's going to be some amount of our C3H8, our CO2s, and our waters. So we're kind of going to use it to backtrack. So C3H8 plus some amount of O2s go to CO2 as a gas plus our water. So this should be 3, this should be 4, this should be 3 plus 2, this should be 5. And so we're looking for this one. We don't know its delta HFs. Well, we know this one's 0. We know this one is negative 393.5. We know that this one is negative 241.8. So we know that the delta H of the reaction is 1 minus 2,220. So this should be delta HF, oh, sorry. This should be 3 times our CO2s plus 4 times our water. Okay, that's our products. Minus, I'm going to make some space here, our C3H8. So 1 times delta HF C3H8, which we don't know, plus our 5 times our 0, which is our oxygen. And so we're trying to solve for this HF. So this gives me negative 2,220 kilojoules is equal to 3 times negative 393.5 plus 4 times negative 241.8, negative 2,147.7 kilojoules minus delta HF of our C3H8. So I'm going to move my negative or my this term over. This becomes negative 72.3 kilojoules. But remember that that's equal to negative my delta HF. And so I need to flip those signs, and that becomes a positive 72.3 for my C3H8. And that's kind of how you can solve that. Okay, I hope that helps.